Hey, what's up everybody? Welcome back to the channel. Today I'm out here at the Lake Wilson Reservoir in Oahu, and I'm just testing out some new modifications I made for my trolling motor setup. Today I'm out here on the FS10 and I've got the Watersnake T24 behind me. I guess the purpose of today's video is I made some changes to the trolling motor. Normally it runs on 12 volts, but I've got it set up to where I could switch it out between 12 and 18 volts. First thing I'm going to do is show you guys how I got it set up to where you could run it on 18 volts. Then I'm going to take it out and get a top speed run on 12 volts and then see how that compares to 18 volts and see if I've made any significant improvements or if I just wasted my time. Alright, so what you're going to need to do this is a trolling motor. This one's just a Watersnake T24. Got it on Amazon for less than $150. You're going to need a pulse width modulator. It's just a motor controller. Again, picked that one up on Amazon. You're going to need your batteries and a battery adapter. This is about $10. I just connected the wires directly to this quick connect for the motor. And you're going to need some heat shrink, soldering iron, wire strippers, something to melt the heat shrink, and then just a couple screwdrivers. So to start this off, we're going to talk about the batteries. You can get this adapter on Amazon for about $10, and it just clips to the top of the Ryobi batteries, and then you could plug your motor directly into this, or you could plug it into the motor controller. These batteries are not waterproof, and if they get wet it will destroy the battery, and they're kind of expensive to replace. So to prevent that, I got this Pelican Vault case, which will hold 4 of these Ryobi batteries. These are 4 amp batteries, so this whole case will get you about 16 amp hours at 18 volts. There's a aftermarket battery that you can get on Amazon that is the exact same size as these batteries, but they are 7 amp hour. These Ryobi batteries, they're made up of 2 sets of 5 18650 battery cells arranged in series, and then the 2 sets are arranged parallel. But these batteries only use 2 amp hour 18650 cells. Aftermarket ones that use 3.5 amp hour cells. So for the same size container, you get 7 amp hours instead of 4 that you get with these. So for this, you just plug this wire straight in to the quick connect. When the battery dies, you just open the case and move this from one cell over to the next. Ideally, I'm going to get 4 of these caps and then run them all in series, so it'll just run all the batteries together. But this is just the test run to make sure everything actually works the way I want it to, so I just got the 1 cap right now and I can move it over as I need to. So then if you close the case, these vault cases are completely waterproof. They have a seal around the rim so no water can get in. And then I just put a quick connect mount on the top of it, sealed that up so no water could get inside it. And then the power cord from the motor controller just plugs in like that. So after the battery is put together, the next thing to do is get the trolling motor ready. Normally, you'd be able to just plug this cable directly in cord on the motor controller, but because this motor is only designed for a 12 volt battery, even using the 12 volt lithium battery that really puts out a little over 14 volts, the motor head gets hot because these switches aren't rated for that much power, so you could burn it out if you try to connect an 18 volt battery directly to it. So for that, I'm just going to take the motor head apart real quick. Now that the top of the head is opened up, you can see that there are 3 wires that come up from the motor shaft. You're going to want to unplug those 3 wires from the switches. Well, we didn't need that one anyways. And then these two wires actually come from the battery. And because this wire is longer and it has the quick connect that I want on it, I'm just going to go a few inches out from where it comes into the motor head, and then just clip it off because I'm going to reuse that for this cable. And then I'm going to get a screwdriver and just take the base of the motor head off. So there's one other thing that I forgot about taking this motor head off. You need to pull the handle out, and then if you look inside there, there are the two little metal clips that hold the wires in place, or it keeps them out of the way of the handle, so it could slide in and out of the head without damaging the wires. So you just get a screwdriver and undo those two clips. And then once you get them out of the way, the head just pops right off. So now that we have this part, or these wires out, this cable here is just for the low speed option that this motor comes with. So you can take it and just tuck it down inside the motor, or inside the shaft, because we will not be using that wire. I'm going to clip these two cables. Next thing, just strip these wires back a bit, then grab the appropriate size heat shrink tubing. I just got this stuff on Amazon. It's got some adhesive lining the inside of the tubing, so when you heat it up, not only does the tube shrink to the size of the wire, it also is self-adhering, so it'll kind of glue itself down and add a little bit of extra waterproofing. From there, you just twist your two wires together, get your soldering iron, and solder it down to form a strong permanent connection. After everything is soldered and you have your heat shrink tubes in place, just use a little bit of fire. Remember to keep moving the lighter back and forth because you don't want to burn through the heat shrink. And just keep working it until it's shrunk all the way down and has a good seal on the wires. So I'm not sure how well it's coming through on camera, but you could kind of see right there around where the red wire is, that layer of adhesive that is all the way through the heat shrink and just provides an extra bit of waterproofing on it. After you got the wiring together, you're just gonna wrap it or the top of the motor shaft in electrical tape or another kind of heat shrink tubing if you have anything, just something to seal off the top and keep the wires together. But before I seal the top, I'd like to plug everything in and make sure it works right. So for that, it's as easy as just take the quick connect that's coming off of the motor and plug it into the output from the motor controller. Then take the quick connect from the motor controller, plug it into the battery, and then put it in forward and turn the controller. And that is noticeably more power than it had when it was 12 volt. The controller has 3 positions: forward, off, and reverse. Because it's a DC motor, if you change the polarization that's going into it, it'll change directions. Not sure if you see here, but it's currently at 65% power. If the base power, or if the base battery is a 12 volt and I increased it to 18 volts, at 65% output power, it should give me the same thrust as 100% on a 12 volt. When this is set up at 100% output, because it has a 50% increase in voltage, it should increase the motor RPMs by 50%, which in turn should give me 50% more speed on the kayak. I contacted customer service and they said that it's only a 12 volt motor and that making any modifications to it will void the warranty. But who cares about a warranty when you could go 50% faster on your kayak? Alright, so I've got the motor control right here. This setup is not the one that I normally use for this kayak. I normally have this set up on my Voodoo. So the cables are a little bit short and the battery is sitting here in front of me. Normally on this kayak I'm just running the switch right here for on and off, and then I have the battery behind me, but we're gonna make it work today. So just flip it forward and we'll start it at 60%, see how fast that gets us going. Again, I'm running 12 volts right now. The steering on this kayak is set up for different motors, so the steering cables aren't long enough, so I have to just use my paddles to steer, but it is good enough for this test run. So I've got 2 miles an hour with the motor at 60%. Gonna kick it up to 100%, see how fast it goes. All right, so seems we topped out at 4 miles an hour on 12 volts. So I'm gonna disconnect it real quick and get it set up for 18 volts. 18 volts is exactly 50% more voltage than 12 volts. So in theory, running at 40% on this should give me the same speed as running 60% on the 12 volt battery, which it is. I'm sitting there at 2 miles an hour. So if I kick this up to 66%, that should get me up to 4 miles an hour. Or at least pretty close to it. So I'm at 3 miles an hour. This doesn't show the decimal, so I can't really say for sure if I'm, or there it goes, there's 4 miles an hour. So let's kick it up to 100% and see what I could get out of it. So I've got a new app that shows speed in fractions. So I'm gonna hook the 12 volt battery back up and run this test again with fractions to see how much of a speed increase I actually got by using the 18 volt batteries. Okay, let's get this set to 60%. Slowly picking up a little bit of speed. Top speed is right at 2.2. Turn slightly. All right, let's turn it up to 100%. Looks like 3.5, 3.6 is going to be the max speed. Okay, let's get this switched back out again. Back to the 12 volt. Sorry, back to the 18 volt. At 40%, I should be able to get up to the same 2.6 or 2.7 that I was on the 12 volt battery. All right, so I'm at 2.3, which is a little bit slower than 2.4, the other motor, at 60%. So let's kick this up to 66%, which should get me pretty close to the same speed that the other motor was at 100%. So yeah, pretty well right on where the other motor was at 100%. So let's see at 18 volts with 100%. Let's check this out real quick. We've used half of this battery. Just gonna pop that off, put it on this one, close the container. Try this one more time with no wind and a fresh battery, and probably be maybe one more test after this, because these wires are getting kind of hot and I think I can smell the motor burning a little bit. Okay, so I didn't exactly get the speed increase that I was looking for, but at one point I did see it peak up to about 4.7 or 4.8 miles an hour, which is more than a 25% increase over the 12 volt power. But in a not surprising but kind of disappointing turn of events, the motor isn't actually turning on right now. Which customer service for the motor did tell me that it's only rated for 12 volts and not to go any higher than that. So I guess I'm not really surprised, but still I was kind of hoping it would work out a little bit longer than it did. Got maybe a total of about 10 minutes running it on 18 volts before the motor just stopped working. So I'm gonna take it apart when I get to my house and see what's wrong with it, maybe see if I could fix it. The 50% increase in power that I mentioned was based on using a 12 volt versus a 18 volt battery. But while these batteries are labeled as 12 volts and 18 volts, they're lithium batteries, so that's not exactly an accurate measure. Each of these batteries, both the 12 volt ampere time that I got on Amazon and the 18 volt Ryobi battery, are both made of 18650 cells arranged in series to give you the desired voltage, and then sets of series arranged parallel to give you the desired battery capacity. The nominal voltage for an 18650 battery cell is 3.6 volts, with the fully charged voltage actually being 4.2. The 12 volt battery consists of sets of cells arranged in a 4-cell series, which actually produces a 14.2 volt nominal charge or a 16.8 volt full charge, while the 18 volt Ryobi battery consists of sets of cells arranged in a 5-cell series. So while the nominal charge is 18 volts, the full charge is actually 21 volts. So with that in mind, the actual power increase from the 12-volt battery to the 18-volt battery when fully charged is actually 25%. So with that in mind, seeing a 50% increase in speed wasn't going to happen regardless of how well the system worked. But we did manage to get a 30% increase in speed. And while 1.1 mile an hour improvement isn't particularly huge, a 30% increase is kind of significant. So one thing that I did notice about the trolling motor when I was running the 18-volt battery, that the lead running from the motor controller back to the motor was building up a lot of heat. Barely even touch it without burning yourself. Which means there was a lot of resistance in the wire and that too much power was trying to flow through it. I did notice that when I was redoing the wiring on the motor, that both of the wires were darker and showed obvious signs of wear and corrosion. So I think a lot of the resistance could have come from that, just having bad wires. I think after I take the motor apart, if I'm able to save it, I'm going to look into rewiring the motor using higher quality wires and seeing if I have better results that way. Because with the amount of heat that it was building up in the wires, obviously not all the power was making it to the motor. I was losing a lot of my energy just through the resistance and heat building up in the wires. If you have a better trolling motor, maybe one of the Koda Endura trolling motors, doing this swap might work out a little bit better for you. It was one of the cheapest and smallest trolling motors they had on Amazon. These Watersnake trolling motors are pretty great for kayaks. They weigh, I think, 7 pounds total for the trolling motor, and they provide 24 pounds of thrust when using them on a 12-volt system without any issues. So they're good motors when you use them how you're supposed to. I just they're not quite durable enough for what I was trying to do with it today. So that about does it for today's video. If you liked it, give it a thumbs up, maybe leave a comment down below, and I'll catch you on the next one.